When you address factorizing using the trinomial method, always make sure that there is no highest common factor between the three terms that have been given to you. If there is a highest common factor, make sure that you take that out first. By not taking it out, you might then end up factorizing, but not factorizing fully, and your answer would not be entirely complete. Now, there are many different ways of factorizing using the trinomial method, and I'm just going to show you the way that I find the easiest to use. In my method, I first identify that I am going to be using the minus type. So that last sign, the sign of the third term, tells me that I am using a minus type of trinomial factorizing. I must always have a plus at the first term for my method to work, and in this case I do. The next thing that I do is I create a trinomial cross. And I look at the factors, which are the coefficient numbers of the first term and the last term. I take the first term's coefficient and I split it into factors at the front of the cross. So the first term coefficient comes to the front of the cross. Well, 2 times 1 is the only way I can get back to 2, so those are the factors for 2. Now I do exactly the same for 1, but because it was my last term, I split it into factors at the back of the cross. And again, I only have one option, because 1 times 1 is 1. Now, because I must minus to find my middle term's coefficient, I'm going to check and see how I'm going to do this. You're going to times across the arms. 2 times 1 is 2. Then you times across the other green arm, and 1 times 1 is 1. Well, if I minus 1 from 2, I am going to get the number that I desire, which is the coefficient of the middle term. All that remains now is for me to figure out which of these needed the minus and which one needed the plus. As my answer is minus 1, and 2 times 1 is the bigger number, the minus goes on that arm, and the opposite sign goes on the other. All that remains is for me to recognize what my variable had been. As my variable had been x, and had gone double the x variables, half the x variables in the middle, and none at the end, I must split my x variables at the front. So 1x at the beginning of the first row and 1x at the beginning of the second row. This is a great method because now each row in fact represents a bracket factor. And if I read the top row off, my first bracket factor is going to be 2x plus 1, and my second bracket factor is x minus 1. When you have coefficients at the front and at the back of your trinomial, it is much easier to factorize using this method because sometimes doing it in your head isn't as easy. Let's practice this skill, but this time we're going to be practicing it with what I would call the plus type of trinomial factorizing. So in this case, because it's plus, I'm going to be adding. Let's draw our trinomial cross again. We can see that the first term is a plus term, and so my method should work. My variables reduce from double, 2x factors, half, 1x factor in the middle, to none. So this should be a very nice trinomial. Take a look at the coefficient at the front, 9. Now if I have 9 and I break it into factors, that's either going to be 1 times 9 or 3 times 3. I don't know at this stage which one I want to use, so I'm going to first break up the last factor. As the last number is 1, I only have an option of 1 and 1. But now I have to add my numbers together and get 6, which means that I'm going to use the 3 and 3 option, because when I cross, I get 3 and 3, and 3 and 3 definitely makes 6. But I wasn't adding plus numbers, I was adding minus numbers, because my answer isn't just 6, it's minus 6. So I must have minuses both in my first factor and my second factor. As my variable was x, and I had double the x's at the front of my trinomial, I'm going to split it at the front of each row, remembering that your top row is your first bracket factor and your bottom row is your second bracket factor. So if I factorize this expression of 3 terms, it's actually 3x minus 1 times by 3x minus 1. Now we know that if we have a factor and it is repeated, in other words, it is identical, then I could actually have written this as 3x minus 1 squared. I said my factor was the same. How many did I have? I had one represented first and then another one represented second. So in fact I've got two bracket factors of 3x minus 1.